Okay, so as Daria said, it's a research plan. It's only for testing and for research. So we have the injection site, and what we need we want to inject the CO2. So what we need a CO2, right? So what they do is they deliver CO2 in a liquidized form, as you can see, in a tank truck or cistern, or whatever you call it, by land transportation. And once it comes, it's pumped into those silos on the left side, on the left picture. So this is the place when they store CO2 in a liquidized form. And once you have CO2, so the next step that you want to do to inject the CO2 is you have to make a well, right? So they drilled few wells, 3 wells, and one of them you can see on the right picture. There's a drilling rig on the right side, and this is how they make a well. On the right picture you have one of the drills they have used to do that, and for some of you, this brighter side is a working surface, which is drilling, and the other red thing is just pulling out the material from down up to the earth, up to the surface. And on the left side you've got a casing, which is once they have drilled the well, they put casing, and into this casing they will be injecting the CO2. And this is quite interesting casing. It's called smart casing, but I will tell you about it later. So they started to inject CO2 in late June of 2008, and on this diagram you can see, this diagram shows you how the total amount of CO2, which is the blue line, and flow rate inside the well, which is red one, have changed within time. Diagram covers the period from June 2008 to February 2009. So as you can see, there were some stoppages, sometimes caused by technical problems, but what's interesting, sometimes caused by CO2 shortage. They didn't have CO2. That's fine, right? Model. This is, as a typical research project, CO2 sink had to be modeled first before it has started, and that included numerical modeling and simulations revealing the long-term fate of injected CO2, and of course subsurface modeling had to be developed. And this modeling process involved many institutions and private companies, which were shown before. And like I said before, CO2 sink in CATSIM is a project. Extremely important thing in modern project management is to manage risk within a project. And the primary challenge for geological storage of CO2 is to ensure that the stored CO2 is retained over a sufficiently long period of time. And the main risks included in the project risk profile are shown in the slide. If you don't do a good job on the risk management, assessment, and mitigation actions, you can end up like those guys here on the left side on the cartoon. They would have to learn to swim probably in a deep CO2 liquidized. Right? So directly from the risk assessment, we obtain some areas of activity that we have to monitor. In case of CATSIM, this would be migration of CO2, injection process itself, caprock integrity and reservoir integrity, to see if there are no cracks, faults, and so on. I don't want to focus on this one. And as I said, smart casing. They are using smart casing. You have seen a part of it on the other slide. It was red on the left side, with cables hanging out of it. Those were sensors. And this smart casing provides very high quality data about pressure, temperature, air, and resistivity. So like that, also like Daria said, there's an injection well in the middle.
You can use them off the point. You can point.
Not really. Oh yeah. I was trying to use it before, but
yeah, you have to shake it to get on the screen.
So we've got an injection well here inside. You've got around the injection well there's a casing, which is smart because they have a whole bunch of sensors all over it. And also we have two wells, this one and this one, which is only for measurements, to measure the migration of CO2 and so on.